Hey guys, Andrew here. I'm going to talk about design today, and I'm going to talk about potential reason why architects, builders, designers, subcontractors don't mesh. And it's actually a reasonably innocent reason that I kind of figured out this morning from an architect that I had a conversation with in Canada, who started to explain to me his design process, how he came from CAD and how he's moving into the 3D world, and some of the frustrations that he's getting as he comes into the 3D world. So let's see if I can help articulate on what he told me and what I learned. Okay, so the first gripe that the gentleman I had a conversation with this morning told me was that he didn't like to be constrained by design at, by structural elements or materials or anything like that. He just wants to design. And so he said to me, well, what I want to do is I actually want to draw a 9-inch wall. So I type in 9 inches there, and I want to go around and just start designing. And this is actually just, I quickly took an overlay of what he was doing there, and I'll quickly just draw a little bit of it. And from this, I can explain what you need to know when you're actually going to be using 3D BIM software. So I drew just from the outside of the wall, but I could have drawn from the inside of the wall. It wouldn't matter. It had no consequence. Once I actually go and start to detail this up and add thickness and materials and products to this wall, it has to change in thickness overall somewhere. Now, that's understood, and I think it's a given. Everyone understands that if you actually draw a different wall type, you're actually going to have a slightly different thickness according to the materials that you've chosen. Now, let's add some materials to the bottom of this one here. Material selections and finishes, and I'll just add some austral bricks here, right? This wall here has a different thickness in multiple spots. Now, that's all well and good, but there is something to consider when you're designing, and something that's really important to consider when you're designing, and that is the location of the structural point. Now, I've actually got another model here that I'm going to have a bit of a look at. So I am mainly talking about residential construction. However, this does follow through into commercial. So we've just got a residential home here, but it just made it easier, not too complicated, easy design for me to actually explain why we should be designing, or we should be thinking about the future of the design according to how it's built. And here's the thing. So here's a section, and previously I drew from the outside of the wall here. However, we're probably all aware that cladding or bricks or anything is actually just a facade. It has no integrity when it comes to holding up the roof. And most of us would have seen a typical design here, or a cross section that resembles this all the time. And I think this is something that's easily missed. So the underside of my rafter and the bottom of my ceiling joist in most cases is the structural point. In some cases the rafter can lift up. However, this point here is the XY line. This is the most crucial point to designing, and I am going to explain why you should just change slightly the way you design to ensure that you can actually have buildable projects. Okay, so let's talk about this from an engineer's point of view. Right. When we design from the ground up 9 times out of 10, and when we build, we definitely build from the ground up because skyhooks are hard to come by. Here's the thing. We design and we build from the ground up, but when a project is engineered or detailed, it's actually designed from the roof down. So all of these red sections you'll see here are really critical to the way this project has to be designed, and this is a simple project. So there's several things to take into account. Number one is the ability for the roof to lift off with wind, and also the weight on the roof that pushes down, right? So every time we design or we build, the critical point of the design is actually the structural point, or the intersection between the underside of the rafter and the underside of the ceiling joist, if there's a ceiling joist. Right, so if I go back to that other model that we had there, let's have a quick look and explain this a little bit further. Yes, we want the freedom to design according to and not be inhibited by material choice or thickness. I get it. But there is a consideration that I think will go a long way to making everyone's job a little bit easier if they take this advice on board. when we're designing a project, it has to fit inside of a boundary. I'll just get out of that and go rectangle. And so here is our project boundary, right? And the project boundary usually has an offset. Now I'm just going to quickly make an offset here of whatever, right? So this might be our project offset. Therefore, when the project is actually built, probably the outside of the eaves or the furthest extremity of the project would fit on that boundary line. So the remedy to it is that instead of designing from the outside wall, at least consider what type of wall you could potentially use. Now I'm not saying actually no, because you know what, that takes a little bit of thought. However, but if you just understand roughly what size that wall is, and you might say, and this was explained to me this morning, the architect said, well, I know if I create an 11-inch wall, when I actually build the project, if I use option A, B or C construction method, it's still going to fit. The problem is that when he drew the wall, he was drawing it from the inside, right, which is not the load bearing point, right? I can do that. He drew from here, right? Now, when drawing from here, I'm now outside of my boundary. So the consideration to do is, instead of what's the overall thickness of the wall, what's the thickness of the wall outside of the load bearing point? And in that case, you would actually design in further. So if I said, let's design from here, and look, I mean, this is not accurate, guys, but I think you get the idea. And we're going to draw our wall from here, right? I now have more grace or more room to actually slide out on the boundary, because the distance that I drew my structural wall from wasn't constrained by a building line or a building envelope, right? Which would be here. We don't want to encroach that. So my recommendation, and something that new to me, is, guys, when you're designing, ensure you design and consider that the external cladding and the internal cladding have no bearing on the structure and no bearing on the ability for the walls to hold weight. So give yourself a little bit more room, and when you redraw a wall from a solid wall to a veneer wall or a clad wall, that you've actually got less work at the time when you've actually put your roof on. Because if you go and draw up a conceptual design, do all of them in a solid wall that you think is 11 inches thick, and you go and put a roof on, and then you go back and you change the thickness of the wall, the roof isn't going to be in the right place, and it's not going to be designed to suit the way that it's actually going to be built. Guys, I hope it helps. It's a little bit of a long-winded help session, but I do think that if you can fathom what I'm saying, I think it's really going to help you out in your career. Cheers, guys. If you like the video, push like. If you dislike the video, push dislike and tell us why. Cheers.